If you try to read the statement of three-sum problem and if you go to the expected output, you will see this is very difficult because just like two-sum, it is not expecting any two indexes. It is asking you the set of all three indexes whose possible sum will be 0. And to make it more difficult, this question gives you an integer array which is not sorted, unlike the two-sum problem, which makes it more difficult. But nothing is difficult when it's come to brute force approach, because in brute force you are free to apply any number of data structure that you are aware of and you can just print the result. So if you just talk about brute force approach, this is the brute force approach method that we are going to use, where we are using 3 loops, and for each loop, as we know, we require 3 set of indexes whose sum is 0. So at a time, one loop can track of first candidate value, and in this way every loop will give you a number which you can just sum and check if it is 0, and once it becomes 0 you can just return, or in this case we have to save in a list so that we can return the list, because as you see this input or the expected output is expecting a list of integer. So the list of integer will be the set of 3 values and making a list out of that also. But the problem is it will take big O of n cube time complexity, which is greater than n square, and later we'll optimize this. Space complexity is k because as we are using list of list, and that is what required also. We can't get rid of that. So let's dive into the solution and let's see how it is work in action. So we need list of integer, and we are using here hash set because we might find some more set of 3 values which can be candidate, but those are duplicate, so we don't want that. That's why I am taking set, and at the end we can result this result set. Now we need these 3 loops. First, start from iterating from the beginning. Second, start from where first left, and third, start from where second left. So in this way, each of the 4 loop will take care of every other possible combination, and whenever you will find if something like this happening, the time complexity naturally increases. Now we have to check every time that if the ith value, the jth value and the kth value sum is 0 or not. If that is the case, then we can just append or add into the list. We can create a dummy list. We can add into the list like triplet list what we have created here, and then we can sort the triplet so that if we find another pair of same set of values, then after sorting, set will not include the duplicate triplet, and then we have to add into our result set. In this way we'll able to add into our result set and we can return this at the end. As this is the first example of Leetcode that I am showing, so we want this output. Let's see. Yeah, we are getting the same. So this was the brute force approach and we have to optimize this. So how we can optimize this? As we are learning 2-pointer approach, and also in the past we have used 2 pointers to solve two-sum problem. So what we are going to do, we can reduce or we can make some changes so that we will take each element at a time, and then for the other set of values in the array, we treat this as two-sum problem. But for that we need sorted array, so obviously we have to sort. So what I am saying is this one, like we can fix a number from the array by using a single for loop, and we can treat the other numbers as two-sum problem, and going forward we can just check if sum is less than 0, then we can move the left pointer. If sum is greater than 0, then we can move the right pointer. But this is all we can achieve after the sorting, and once we get the triplet, we'll just save that, and at the end we will return the list of list. Now let's come and see this one. So first we are using for loop to iterate the initial array given. Before that we are just doing a sort. If interviewer ask, just use merge sort, because sometime it is expected that not to use any inbuilt function for sorting. So you can use the merge sort. And here we are taking list of list. And for conditional check, what we are doing is we are just checking if I is greater than 0, and if num I is equals to the previous one, then we'll continue. So this condition is sufficient to ignore any duplicate number to add. Now as usual, we are taking 2 pointers. If you haven't watched my 2 pointer series, then please go and watch, because this will make more sense after that, because at least you should aware how 2 pointers work, but I will tell you in this one also. So we are doing while loop and we are checking condition each time so that left pointer do not overlap the right pointer. Also we are checking if what is the current sum, and for every sum we are checking when it is 0 we will add that triplet. As simple as that. Once we add it, we can keep on checking if the current number where left is pointing is equals to right or not. If that is the case, that we do not want duplicate, and what we have done in line 18 we will do here also. Same for the right one, because this is the only way to reduce the possibility of duplication. And for every iteration, if we found a triplet, we will simply increase left pointer and right pointer together. If that is not the case, as we discussed in that image, if sum is less than 0, we will increase the left pointer. If sum is greater than 0, or we are just left with one condition, so I'm just writing else, it will just decrease the right pointer. And at the end, we can return the list. Let's see and check. So here is our triplet, which is what we are expecting. Now let's try to run in the Leetcode. Now here is our Leetcode, and we are just trying to run it, the same thing that we have built there. Now we are testing for simple test cases. It is all passing. We can submit this to check further. So yeah, we are approximately beating 43% of the programmer, but we are following the pattern, the 2 pointer approach, and we have successfully completed this in optimal way in n square time complexity, and that is intuitive also. From 3 for loop we have just reduced that, and we have achieved the n square time complexity. We might take this example further and we can optimize this later in different pattern, but for this one, as we were learning 2 pointer, this is sufficient. Alright guys, see you in the next one.